Hi there, internet people. Today I'm going to talk about bisecting software. So to get to why this is necessary sometimes, and depending on who you are, here I have a bug that I filed against NVIDIA for their external monitor. If I use the latest drivers on my Linux system, the external monitor doesn't wake up when it's connected with HDMI or a DisplayPort cable, and the computer goes into sleep mode and then comes back up. That monitor does not wake up if the refresh rate is higher than 30 Hz. So to get around this problem, I've installed a slightly older version of the same drivers, and that seems to work. But anything beyond that, I don't have any control over. My hands are tied. It's completely up to NVIDIA, who make closed source drivers for their cards, to see if they can fix the problem, if the problem is big enough to fix. So for them it's quite a heavy lift, because they've got to recreate my setup and then try to fix it. And there's nothing that I can do beyond file the bug report, say when it works, when it doesn't work, and then hope for the best. And this is the problem with closed source community. Stuff like Windows, that sort of thing, they all suffer from the same thing, in that if you run into a problem, you can't fix it. You simply have to hope that it affects enough people so that they can give it a go. So there's another bug that I've got a report on here. Let's bring that up quickly. Oh, not that one. That one. And F11 it nice and big, so that you can follow along. And here we go. I've filed a bug with a kernel, on the Linux kernel, and I'm saying kernel version 6.13 release candidate 4 is not powering off the laptop. And what this means is, when I tell the computer to shut down, everything stops, but the power itself is not being shut down. And when I say restart, it doesn't do it as well. So in version 6.12, any of its after ones, this is not a problem. So of course, here I go, give it a little bit of, as much of a description as I can, to make sure that this actually, it piques the interest of the developers, because their systems are all different and none of them is like my system. So if there's a bug, it's gonna affect people at some point in the future, and we try and avoid that sort of thing. So as you can see here, my laptop is a nice and powerful 32 times AMD Ryzen 9. It's a nice meaty laptop. Asus, Republic of Gamers, Strix, SCAR 2023 version. So it's a nice laptop to say the least. So here we go, and one of the guys responded here to me, and he says, please bisect. So this is one of the standard responses, and honestly something that I've been asked to do before, and I was never able to. So today we actually have a working bisection. So because I'm running Arch Linux, there's lots and lots of help for that. So I'm just gonna F11 this guy small, and on the bisection, let's just get it nice and big for you guys. So bisecting bugs with Git. So it tells you to find a version that's working and a version that's not working, and then you can set up your bisect here, go to your Git roots, and you start. Right, so how does that work in practice? So I'm busy with my kernel, and well, let's just minimize this guy off the background. Right, and get it nice and big so you can follow along. So first let's surf to where I keep my kernel sources. So Right, so if we do an ls here, I'll just make it a little bit smaller, do another ls. So alright, so ls, there we go. Okay, so these are the files in the Linux kernel, and you can see I've put a couple of builds up already. The first two were good, and then they were bad, good, bad. That'll become clear later. So there's also a source subdirectory, and then there's a source bisect. So let's go ahead and move source to source dot example, because I'm not going to mess up the source that I'm busy with. And now we're just going to do a cd to source. Oh, let's just get this keyboard properly here. Example, and then there's a Linux manual. So if we go back to our instructions here on how to do this git bisect, we can just drop it down there, and it tells you to go to that one, and you do a git bisect start, and then waiting for good and bad commits. So it wants to know the first one that was good and the first one that was bad. So for me to figure out how to tell it, so let's just do a git tag, and that just displays all the tags that there are. So 2.6.13, 3, 4, 5. So there's a lot of kernel versions. It's a very active project. But up here, this is the ones we're interested in. Release candidate 7 would be the last 6.12, and that one I know works. And release candidate 13, I actually picked it up in 4, then I installed release candidate 1, and it was still there. So it's between these two versions. So I'm just gonna quit out of that and then say git bisect. Good was v6.12, release candidate 7, and then git bisect bad was v6.13, release candidate 1. And then it figures out, it says there are 6,335 revisions to left to test, and that was 13 steps. And then it gives you this commit. So this one is somewhere in the middle, and all you're doing is a binary search. So you basically going to try and figure out which one of these commits caused the problem. So binary search is the quickest way of doing it, but it is quite a lot of things that go in there. So each time you build a kernel, that takes a little while, a couple of minutes on my system, probably a little bit longer on some other systems. So let's not do that. Let's carry on with where I was busy with. So let's go source.bisect, and then Linux mainline. So git bisect. Now the last one that I was running was bad. So I'm just saying bad, and bad means it has the problem. So it says there are 52 revisions left, and we'll get to that in 6 steps. And it gives me a commit to try. So I'm just going to copy that one and go back. So do my little ls here. You can see they I'm just to keep track of where I am in the process, so that I can stop it and go do something else and then come back. I'll just copy my package build, which is arc specific, to package build and build 7, and that one I'm just marking as bad. Now I'm just going to edit package build, go down to this commit, which was the previous one, take it away, add in the proper one, save it, close it. And then just as a sanity check, I'm also sticking in a journal control of the last boots, I'm just interested in the first line, so I'm just going to do a head -1, and that's the output of that. But I want to save it, so I'm going to put bold 07 underscore journal bad.txt. So as you can see there, it actually tells you a shortened version of the commit that you were testing there. So that's done. I've set up my package build for the new one, and now we just tell Arch Linux to forcefully build it and install the package. And there it goes. And while I'm doing that, I'll just switch my system into turbo mode, so it's going full speed. It checks out the new source because I've removed the source in this case. Figures out the config, kicks off, and there you go. Now it's starting to build the kernel, and you can hear my laptop spinning up there as it's all heating up. And the purpose of this, of course, is once I find this bug, I can then stick it back to the developers and say, this specific commit caused this bug for me, and we can investigate it and see what exactly it was that was making this issue, and hopefully we can fix it, and then the problem just goes away in my system. So to get back to my original point, this is the true power of open source. If you're just a little bit interested and you know how to build software, and Arch Linux is really easy to do that, you can just go ahead and fix your own problems. And so if, for instance, you run some really interesting hardware, you are going to find more problems. So I picked this specific laptop because the build quality is great, and I've got no fear of running into problems. We fix it as we go along. So Aces has a really good community, online community, that gives you a hand and gives you little tips and tricks of things to try when you do run into bugs. So I would highly recommend getting an Asus, and if you have a bit of spare cash lying around, get an Asus Republic of Gamer SCAR laptop. These things are super powerful. Plays all sorts of games really nice, you know. Even older titles like Doom, I get 200 frames a second on. This thing is a gamer's dream. I do some video editing on it, of course, as you can see, and every now and then I run into a small little hardware issue, and why not fix it? Why not get it all fixed? And the thing is, if you have something similar and you can't fix it, just wait a little while and somebody else will fix it. So if you guys never run into this problem, you're welcome. And I hope you all have a really nice day, and goodbye.